Our ultimate goal in bringing you the Crossbow Safety and Education video series is to provide you with a full understanding of the crossbow, how it works, how to properly shoot one, and to introduce you to some basic methods of bow hunting with a crossbow. However, in order to learn everything you need to know about crossbows, we must first take a look at the components that make up a crossbow. So let's take a look at a common compound crossbow and define the components that make it up. Okay, so a crossbow is primarily constructed from two key components, the stock and the bow. But we're going to take a deeper look into the actual components that make up the stock and the bow. Let's start with the bow. The bow of a compound crossbow is made up of four key components. We have a riser, which is the metal piece that bolts onto the end of the stock or barrel. We have limbs, which your crossbow may have 2 or 4, and the limbs give the bow its power and they bolt on to the end of the riser. At the end of the limbs, you'll find a wheel, which are most times referred to as cams. And then connecting the cams together, you'll find one string and 2 cables. Now, if you have a recurve crossbow or a reverse draw crossbow, things might look a little different on your bow. On a recurve crossbow, you won't have the cams and you'll only have one string. If you purchased a reverse draw crossbow, you'll still have all the same components that we just went over, but they'll be in a different location. In the next segment of the Crossbow Safety and Education series, we'll go into detail about different bow technologies. But for now, we'll focus on the traditional compound crossbow, like this Wicked Ridge here, because it's the most widely used platform. Okay, onto the stock. The stock is the part of the crossbow that you'll be holding. It has 3 main areas. The butt of the stock that you pull up against your shoulder when you're aiming or shooting the crossbow. The forestock, which you hold with your hand opposite of the trigger hand. And the grip, which is where you'll place your trigger hand. The grip can be of traditional design, like you'd find on your favorite shotgun or rifle, and like you see here on this Wicked Ridge crossbow. Or you'll find that many crossbows will have a thumb hole style grip. But the stock also has many more components. One of its jobs is to house the rail or the barrel of the crossbow. The barrel of the crossbow is where the crossbow arrow will sit when loaded, and its job is to guide the arrow when the bow is fired. Some barrels are molded into the stock and are one solid piece, like you see on this bow. Others are manufactured from an aluminum extrusion and bolt into the stock. At the end of the barrel, you'll find the trigger housing. Now, most trigger housings are also comprised of multiple components, including the string latch, which holds the string back when the crossbow is in the cocked position, the trigger, which will fire the crossbow when you pull it, a safety mechanism of some sort, which prevents us from accidentally pulling the trigger until we are ready to fire the bow, and on many models, you'll find an anti-dry fire prohibitor or mechanism, which prevents us from firing the bow without having an arrow loaded. And then last, we have the sight bridge, which will hold your sight of the crossbow. Now on this particular crossbow, it's equipped with a scope, which is probably the most common sight that you're going to find on a crossbow. But you can also use a red dot or a halo type sight if you like. Also, on the front of the sight bridge, you'll normally find an arrow retainer of some sort that aids in keeping the arrow in place when moving the crossbow into different shooting positions. Now, the last component that we'll look at is the foot stirrup. The foot stirrup of a crossbow is the area located at the very front of the bow, and it's where you put your foot in when you're going to cock the crossbow. Sometimes they are mounted directly to the riser, or sometimes they can be mounted to the end of the barrel. And in some models of crossbows, the foot stirrup is actually incorporated as one piece into the riser itself. Well, we covered lots of information in this segment of the Crossbow Safety and Education series, and you should now have a better understanding of the components that make up a crossbow and what they do. In the next segment, we'll take a look at the types of crossbow bow technologies. The bow assembly of a crossbow is what creates the energy needed to propel an arrow. There are two primary types of crossbow bow assembly configurations, the recurve platform and the compound bow platform. And in recent years, compound crossbow technology has expanded to include a couple variants. These variants include inverted cam technology and reverse draw technology. Now, each platform may have its advantages, but in this segment of the Crossbow Safety and Education series, we're going to take a look at each bow technology and explain what makes them different from the next. The first bow we have here is a recurve crossbow from Excalibur Crossbows. Recurve bow technology has been around for thousands of years, and for good reason. It's very simple and yet very effective. As you can see here, a recurve crossbow has two limbs connected to a riser and one string that connects the limbs. As the string is pulled back towards the trigger assembly, the limbs compress and the draw weight of the bow increases. When the string is pulled all the way back to the point where the latch engages, the recurve bow reaches its maximum draw weight, which will be determined by the make and model of your crossbow manufacturer. Next, we have a traditional compound crossbow from Camex Crossbows. We already know a compound crossbow has two limbs connected to a riser, a cam on each end of the limbs, a string, and two cables. Now, with a traditional compound crossbow, the string is located on the back side of the cams. When the string is pulled back, the cams rotate outward, which compress the limbs of the bow, while at the same time allowing the string to gain length so that it can reach the trigger latch. Now, it used to be On most compound bow assemblies, when the string was drawn, the bow would reach its maximum draw weight at some point during the draw cycle and then actually go down in poundage before the string reached the latch. This was called let-off. However, on some of the more current compound crossbows, the cams have been engineered in a way where they may not actually have any let-off at all, and the bow reaches its maximum draw weight at some point during the draw cycle and then remains at that draw weight until the draw cycle is completed. The inverted cam crossbow, like this one from Parker, looks and behaves just like a traditional compound crossbow, but with one major difference. On an inverted cam crossbow, the string is located in the front of the cams. When drawn, the cams rotate inward and the string is pulled through the bow assembly instead of coming off the outside of the cams. This allows the bowstring to travel a longer distance without extending the overall length of the crossbow. Here we have a reverse draw crossbow by Scorpid Crossbows. As you can see, reverse draw crossbow technology looks a lot different from the other two types of compound bow technology we just went over. However, the mechanics work pretty much in the same way. With a reverse draw crossbow, you still have two limbs connected to a riser, two cams connected to the ends of the limbs, a string, and two cables. The big difference here is that the riser is mounted behind the strings and cables, either halfway down the barrel or sometimes even behind the trigger assembly, and the limbs point forward towards the front of the bow. Just like the inverted cam crossbow, the string is drawn through the bow assembly and back towards the trigger assembly until the string is latched. Well, that's it for the crossbow bow technology segment of the Crossbow Safety and Education series. Now, we just scratched the surface when it came to explaining the differences between each bow assembly, and while we could have went more into depth explaining how each technology works specifically, our goal was to inform you of the 4 types of bow technologies that you'll find on today's modern crossbows, so that you'll be able to recognize them when you choose to purchase your first crossbow. The safety and anti-dry fire mechanism on your crossbow are designed to keep both you, the shooter, and your bow safe from injury and or damage. And I thought it was important to take a more of an in-depth look at crossbow safeties and anti-dry fire mechanisms. So on this segment of the Crossbow Safety and Education series, we'll show you a few examples of the types of crossbow safeties you can expect to find on today's crossbows. We'll also show you a few examples of anti-dry fire mechanisms and explain what makes each of those different. Let's take a look at safeties first. Every crossbow will have a safety of some sort. Yours may be auto-engaging, meaning that when you cock your crossbow, the safety will automatically move from the fire position to the safe position. Or you may have a safety that requires you to manually put it in the safe position after your crossbow is cocked. In either case, it's a good habit to visually check to make sure that your safety is indeed in the safe position after you cock your crossbow. Some safeties will be located either on the trigger housing just underneath the sight bridge, and others will be located at the back of the trigger housing or in front of it, located somewhere in the barrel of the crossbow. So let's go over some examples of crossbow safeties. Okay, the first bow we have here is a Carbon Express crossbow with an auto-engaging safety located on the side of the trigger housing. Watch when the bow is cocked, the safety will move from the fire position to the safe position. Okay, here we have a Parker crossbow with a rear-mounted auto-engaging safety. As the string would come back into the latch, the safety moves into the safe position. Okay, last we have a mission crossbow with the safety located in front of the trigger assembly, and it's mounted in the barrel right here. Okay, when we pull back on the string, the safety will not move, so you must manually put it into the safe position. The bow is cocked, we push the safety from the side, and now you're safe to go. Okay, next we are going to take a look at 3 types of anti-dry fire mechanisms. The first one we have here is from Camex crossbows. And the way theirs works is that it won't let you put the crossbow into the fire position without having an arrow loaded into the crossbow. They have what is known as the PAR, and that's this red thing you see here, and it stands for Pivoting Arrow Retainer. And what it does is hold the arrow in place when you slide an arrow between it and the barrel, and then at the same time there is a lever that will pivot out of the way of the safety, allowing you to move it from the safe position to the fire position. So right now there's no arrow in it and you can't push it into the safe position. Now watch as I slide this arrow back. The lever moves out of the way, and now we could put the bow into the fire position. I'm going to put it back in the safe. We're going to remove our arrow, and now it won't go back into fire position without an arrow loaded into the bow. So that's how the Camex anti-dry fire works. The next bow we have here is a Wicked Ridge crossbow. Now with both the 10-point and Wicked Ridge anti-dry fire mechanisms, they actually allow the safety to be moved into the fire position and allow the bow to be shot without an arrow loaded. But then the anti-dry fire mechanism catches the string before it has a chance to do any damage to your crossbow. Now, I don't have an arrow loaded all the way back here, and you can see that the lever on the ADF is down. Once I move the arrow back, the lever will move out of the way and allow the bow to function properly, and you can shoot this crossbow. But without an arrow loaded into the bow, the string will still be allowed to be released by the latch, but this lever on the ADF will actually catch the string and prevent any damage. So I'm going to show you how that works right now. So right now the lever's down. I'm going to slide this arrow back, and the lever goes up. Now this bow would function how it's supposed to, and you can fire this arrow. But I'm going to remove the arrow, the lever goes down. Now I'm going to actually put the bow into the fire position and pull the trigger. And as you can see, the ADF catches the string and the bow doesn't fire, the limbs don't go forward, the string doesn't go down to its resting position, and the bow's perfectly safe. We'll just have to recock it again, and then we'll be ready to go. So that's how the 10-point and the Wicked Ridge anti-dry fire works. The last anti-dry fire mechanism we'll show you is on a Parker crossbow. With Parker's system, the safety can be put into the fire position, and then the trigger can also be pulled, but the latch will not release the string unless an arrow is loaded into the crossbow. And I'll show you how this one works too. So here we have our bow. We currently have the safety is in the safe position, and as you can see, the bow's cocked and there's no arrow loaded. So we're going to go ahead, put it in the fire position, and then pull the trigger. And as you can see, no dry fire. Well, we just took an in-depth look at the most popular styles of safeties and anti-dry fire mechanisms. As stated before, these devices are here to help ensure our safety as crossbow hunters and to prevent our crossbows from damage in case we forget to load an arrow and have an accident. However, even though these safety devices are here to help us, it's truly the responsibility of the crossbow shooter to practice safe shooting habits each and every time you shoot your crossbow. Hunting with and shooting crossbows can be a very rewarding experience. There isn't a greater feeling than watching your arrow hit the center of a bullseye or disappearing behind the shoulder of that big buck. A crossbow can bring a great deal of enjoyment even during a practice session. However, if safety precautions are ignored, a crossbow can be a very dangerous weapon, both to the crossbow shooter or to whatever is in the line of fire. Serious bodily harm can be prevented as long as you know what areas to keep an eye on and avoid. Now, I like to call these areas crossbow danger zones or hot spots. And in this segment of the Crossbow Safety and Education series, we'll learn what and where they are so that you'll be able to experience years of safe crossbow hunting and shooting. The first area of concern is the front of the bow. Just like any firearm, you never want to point a loaded crossbow in the direction of anything you aren't okay with shooting an arrow into. Now, this sounds like common sense, but even with the safety on, you should never point your crossbow in a direction other than a target or the animal you're hunting when it's loaded. The trigger is the next danger zone. Not all crossbows are created equally. Some crossbows have auto-engaging safeties and some don't. If your crossbow isn't equipped with an auto-engaging safety, then the first thing you'll want to do after you cock your crossbow and before you even think about loading an arrow into it is to put the safety on. And if your crossbow does have an auto-engaging safety, don't take for granted that it'll work every time. Chances are it will, but it's still a good idea to always do a visual check before loading an arrow into your crossbow. The string path is the next area of concern. After a crossbow is cocked, you never want to stick your hand in the path of the string. One of the most common crossbow injuries is when a hunter gets ready to take a shot and either their finger or their thumb is above the rail. A crossbow string can have so much force that it can remove fingers and thumbs that get in its way. The good news is that manufacturers are taking safety as serious as ever, and many of them are incorporating safety features either into their stock's foregrip or into the barrel itself to make it nearly impossible to get your fingers above the rail and into the path of the string. Another time you may inadvertently place your hand in the path of the string is when you are carrying or reaching for your crossbow from the top. Because the barrel is in the center of the crossbow, from a balance perspective, it just makes sense to grab your crossbow in the center. Now, this isn't a problem if your crossbow is uncocked, but on a cocked crossbow, you run the risk of serious injury if the bow should fire or fail while holding it in that location. So just remember, anytime your crossbow is cocked, whether it's from the bottom of the crossbow or from the top, you never want your hand or fingers to be in the path of the string. The last area of concern would be with your arrows. Now, most manufacturers will specify a certain type of nock that they recommend shooting from their crossbows. You should always follow the manufacturer's guidelines when it comes to the nock you shoot. Not doing so can result in the string not fully making contact with the back of the arrow when released by the latch. As a result, it can pass underneath or over top of the arrow, leaving you with what is known as a partial dry fire. This can cause damage to the crossbow or injury to the shooter. Another way you can experience a partial dry fire is when using an arrow lighter in weight than what the manufacturer recommends. So always use an arrow with the correct nock and the correct recommended weight when shooting your crossbow. The last thing you can do that can cause yourself injury or damage your crossbow is what is known as a full dry fire. This is when you cock your crossbow and you forget to load an arrow and then fire the crossbow. Unlike a gun, where the firing pin is the only thing that is moving when this happens, the crossbow has a great deal of stored energy in the limbs that transfer to the string the moment that the trigger is pulled. If there's no arrow to absorb that energy, the bow and its components are left to absorb the energy, usually resulting in broken strings and cables and/or cracked limbs. Now, many crossbows have an anti-dry fire mechanism that helps prevent this from happening. But the best way to prevent a dry fire is to always double check that you have an arrow loaded in your bow before firing it. Well, hopefully I didn't scare you too bad. As long as you double check to make sure that you aren't doing any of the previous mentioned safety hazards, shooting your crossbow will provide you with years of safe enjoyment. Making a conscious effort to learn what not to do when you first learn to shoot a crossbow will soon turn into second nature safety habits that will save both you and your crossbow from harm. There is a misconception that modern-day hunting crossbows shoot bolts, partially because in the past crossbows did shoot bolts, and partially because some arrow manufacturers still market their arrows as crossbow bolts. But today's crossbows shoot arrows, and as a crossbow hunter, you have many options in the arrows you will choose to shoot. You have options on the material your shaft is constructed from, what weight point you want to shoot, the length and the style of fletching, and the type of nock you need. So in this segment of the Crossbow Safety and Education series, we'll be discussing the components that make up a crossbow arrow and go into detail on what makes them different. The first part of the arrow we'll discuss is the arrow shaft. Arrow shafts can be built from two main types of material, either aluminum or carbon, and each type does have some advantages and disadvantages. With an aluminum shaft, you'll get more consistency from arrow to arrow as far as arrow weight, arrow spine, and arrow straightness are concerned. However, aluminum shafts tend to be a bit more heavier than carbon shafts, and they can have a tendency to bend or crease easily when shooting tight arrow groups. Carbon arrow shafts are lighter and more durable than aluminum shafts. They hold up better to abuse from other arrows hitting them when group shooting and tend to be a bit more resistant to bending. However, some carbon arrow shafts can be inconsistent in spine even when from the same batch, and you may find that you will get one or two out of a dozen that may not group with the other arrows from that same group. The insert is the part of the arrow that allows you to screw in a practice point or broadhead into the arrow shaft. Inserts can be made from plastic, carbon, aluminum, and/or brass. Generally, you'll find that aluminum arrow shafts will contain the plastic, carbon, or aluminum style inserts in an effort to keep the total arrow weight down. The brass inserts are generally found in carbon arrow shafts. Because brass inserts weigh more, they help increase the total arrow weight when using the lighter carbon arrow shaft. In the end of the insert, you'll find a point of some sort. When practicing with your crossbow, you have a practice point, often referred to as a field point. Field points come in different shapes and weights, with the most common weight for crossbows being 100 grains. A broadhead is the type of point you'll use when hunting. The two main types of broadheads are fixed-bladed and mechanicals. Fixed-bladed broadheads have blades attached to them in a fixed position. The most popular styles have either 3 or 4 blades. The height of the blades will determine the overall cutting diameter of the broadhead. A mechanical broadhead has blades that will move when coming into contact with the animal. They generally have a smaller diameter when shot from a crossbow and then open up to a diameter much larger than fixed blade broadheads after striking the animal. However, mechanical broadheads aren't legal in every state, so you'll want to consult your state's game laws before deciding on hunting with mechanical broadheads. No matter what type of broadhead you choose, you should shoot the same weight as your practice point. And don't take for granted that broadheads will shoot in the same point as your practice points. Oftentimes they won't, so you'll need to practice with your broadheads too. At the back of the arrow, you'll find the fletching. Arrow fletching can be made from feathers or plastic. However, plastic has become much more popular because it is more durable. Most crossbow arrows will have 3 fletchings, often referred to as vanes. However, there are some crossbows that will shoot an arrow with 4 fletchings. The vanes come in different lengths, from anywhere from 2 inches long to 5 inches long, and they can be attached to your arrow in different configurations to promote more or less arrow spin when shot. Most crossbow arrows will have a cock vane, and that is the odd-colored vane which will always point downward into the rail of the crossbow. The end of the arrow that comes in contact with the string is called a nock. Your nock may be plastic or aluminum and can come in different configurations. Most crossbows will shoot either a flat nock, which is squared off at the back, or what is known as a half moon nock, which has a half crescent cut out at the back of the nock to promote better string engagement. The flat nock can be loaded with any of the vanes in the downward position. The moon nock, however, must be indexed correctly to your string or you risk potential damage to your crossbow. Now, because of advancement in crossbow technology, in recent years we have seen a few more styles of crossbow nocks start to emerge. The Omni nock from 10-point crossbows is a nock that engages the string like a moon nock, but allows you to still load your arrow with any vane in the downward position like that of a flat nock. Parker crossbows have come up with a nock called the capture nock that actually has a deeper throat in it to actually encompass the string. And Fire Nock, which builds a line of aftermarket nocks, has come up with a full containment style nock, much like that of a traditional bow that actually snaps on to the crossbow string. So what nock should you be using? Well, the manufacturer of the crossbow you shoot will recommend the type of nock that works best from their crossbows, and you shouldn't deviate from their recommendation. Doing so could result in damage to your bow or possible injuries to yourself. So that's it. We covered lots of information regarding the components that make up a crossbow arrow, but one thing we didn't cover was arrow length. Your manufacturer would determine what length arrow works best out of your crossbow. Most times your arrow will be either 20 inches or 22 inches long. As a rule, always follow the guidelines set forth by your crossbow manufacturer. Deviating from their recommendations are not worth the risk of damaging your crossbow or worse, getting injured over.